Hello class. Today we are going to be exploring how to make a solution. In chemistry, it's an extremely important skill no matter what level you are at. So if I, for example, wanted to make let's say a 1 molar solution of sodium chloride, how would I do that? Well, what is molarity, right? 1 molar, what does that mean? Well, that means 1 mole per liter. 1 mole per liter. So in chemistry, how would we then make that solution? Well, one of the things we are going to use is a volumetric flask. These are pretty much exclusively used for making solutions. This is a 500 milliliter volumetric flask, and on this volumetric flask, I'm not sure if you can see it in the video there, is that line. Now, that line right there is the fill line where if I filled it up to there and the bottom of the meniscus was touching that line, that would be exactly 500 milliliters. So we're going to be using a 500 ml flask, volumetric flask, in order to make our solution. So if I'm using a 500 ml flask, how then will I make my sodium chloride solution? Well, we're going to need 1 mole of sodium chloride per 1 liter of solution, but we only have half a liter, so we're going to need half a mole of sodium chloride in order to make that solution. Now, how do I get half a mole? Am I going to be counting atoms? No, of course not. That would be ridiculous. I'm going to mass it out. So if the mass of sodium chloride, the molar mass that is 58.44 grams per mole, that means if I wanted to make my 1 molar solution, I'm going to need 29.22 grams of sodium chloride, which is exactly what I have right here. So I'm going to take my 29.22 grams, I'm going to put it in my volumetric flask, and I'm going to add some water. Now, I'm not going to add 500 mils because I want to add some and dissolve the salt first. By stirring, by agitating, what am I doing? Why is it that it'll dissolve faster when I agitate it? Well, that's because I am allowing fresh solvents to come into contact with our sodium chloride. But if we were just to let it sit on the counter, you would have to wait for that saturated sodium chloride solution to leave and diffuse out from the interface where the solid salt is interacting with the water. So, by swirling it up, we are increasing the rate of dissolution. And once our salt is pretty much dissolved, we are going to fill this up to exactly 500 mils. Now, this is not the best desk for this, but you want to get eye level with your flask, and you are going to fill it up until you reach that 500 milliliter point. And the last little bit's going to happen pretty quick here. Oh, I overshot it. Just by a little bit. I'm going to cheat a little bit. There we go. So, normally I wouldn't be doing this with a large beaker. But there we go. We have now our 1 molar solution of sodium chloride. Now, again, you wouldn't want to put the 500 mils and then add the salt. You'd find that your volume goes up a little bit. You always add the salt first. You want to dissolve it with a bit of water. and then you fill to your desired volume to get your appropriate concentration of solution. Okay, let's go through those steps one more time, and let's explore this using a little bit of mathematics as well. So, in making a solution with a solid solute and a liquid solvent, we follow those basic steps I laid out. We determine the mass of solute needed. It was 29.22 grams of sodium chloride. We add the solid to a volumetric flask with the desired volume. If I wanted to make instead 2 liters of solution, I would use a 2-liter volumetric flask. Here I just wanted 500 mils. You fill the volumetric flask about half full of solvent, and you swirl to dissolve that solute, and then you will fill to your desired level once it is dissolved. Now, one step I did skip out on, you should stopper it, cover the top of the flask, and you should invert it to ensure that the concentration of your solution is uniform. In fact, you can see that without doing that step, you can actually tell by looking at this. Look how cloudy this bottom part is compared to up here. You can see it's much more concentrated near the bottom than up top. You would want to invert this a couple times to ensure that the concentration is uniform. Okay, now let's look at a couple examples. Describe the steps needed to make 500 milliliters of a 0.1 molar solution of sodium hydroxide. Now, given this information, we need to think of those steps. So how is it that we make a solution? Well, we must take that solid sodium hydroxide, we must add it to our volumetric flask, add a little bit of water in there, swirl it around, and add the rest to the desired volume. But in order to do that, we need to know how much sodium hydroxide we're going to need. Now, how do we figure that out? Well, given that volume and that molarity, you can determine the number of moles of sodium hydroxide you will need, and thus the mass. So, our concentration is going to be our number of moles over our total volume. Therefore, if we want to find moles, that is going to be our concentration times our volume, or 0.1 molar times 500 milliliters. Would it be wrong to write 500 there? I know you might be tempted to. Would that be wrong? Yeah, of course. Why would that be wrong? What's our units of molarity? It's moles per liter. So we must have our volume in liters as well. And 500 mils is 0.5 liters, which means that we have a total number of moles of 0.05 moles. 0.05 moles. Now, what else do we need to know to figure out the number of grams of sodium hydroxide that we need? Well, we need to figure out the molar mass of sodium hydroxide. That is 40 grams on the nose. So, we take our mole value, we multiply this by our molar mass. There's 40 grams of sodium hydroxide per mole, which means that we need 2 grams of sodium hydroxide. So we would take 2 grams, we would put it in our 500 milliliter volumetric flask, we would add some water, we would swirl it up, and then we would add water to that 500 milliliter mark, stopper it, invert it a couple times to ensure uniform concentration, and bada bing bada boom, we have our 0.1 molar solution of NaOH. Let's do one more example. What mass of sodium chloride is needed to make 0.25 liters of a 0.1 molar solution? So again, we are going to follow the exact same steps. So we know our desired concentration, we know the volume we want. We need to now determine what mass of sodium chloride is going to be necessary. So again, if our concentration is our moles over our volume, in order to figure out the number of moles that we need, we must multiply concentration times volume. This is going to be 0.1 molar times 0.25 liters, which gives us a mole value of 0.025 moles. So we know how many moles of sodium chloride we're going to need. Well, I wish I picked easier numbers for this. So now we need to figure out, well, how many grams is this going to be? So what is the molar mass of sodium chloride? Well, that's 22.99 plus 35.45. It's 58.44. So 0.025 moles times 58.44 grams per 1 mole. And this gives us 1.46 grams of sodium chloride needed to make our solution. Alright class, that is it for today. Have a lovely day.